Assalamualaikum and a very good day to you. So we are from group 5 for subject MEC623, System Identification. This group consists of 4 members, including me, Irfan, Haikal and Zahir. In this video, we are going to explain the details about our problem-based learning project, which we call Study Crank. So for the first part, I am going to brief a little bit about our project. So Study Crank mechanism is defined as a set of mechanical parts that convert straight line to rotary motion, such as reciprocating piston engine. This mechanism also can convert rotational to straight line motion, like reciprocating piston pump. So in this project, we will use 3D printing technology to fabricate most of our parts and utilize the Arduino Uno as the main processor for the system. Our objectives in this project is to set up a functioning conceptual framework of a slider crank mechanism utilizing 3D print technology. Next, to create a proper slider crank mechanism design using CAD software such as SolidWorks in order to implement the 3D print technology. And last but not least, to study about the correlation of RPM and translational acceleration.
In this problem statement, I'm going to show you the theoretical problems that we have chosen from dynamics books relating our mechanism, which is slider crank. So here it is, the slider crank mechanism. However, the theoretical problems of this question is actually have been altered, since one of them are these dimension. We have implement the actual dimension of a mechanism that we have designed and fabricate, and then we have changed the question on the rotation speed, which in the question at first the question mentioned the rotation speed. However, in this experimentation, this mini project, we will want to try the speed at variable speed at a variable rate. So we have made it variable rotation speed. So since we're using stepper motor, the maximum speed is 12 RPM. So we will start from rotation speed of 12 RPM and decelerate the motor gradually. So from this question problems, we just built the exact same mechanism. We designed it and then 3D print the components, the disk, the link, and then the slider, and apply motions using electronics using Arduino. Next is the methodology. So it's quite the same from previous explanation. We start from problem statement, which is shown in the previous slide, and then the work is divided into two. First, focus on electronics, what sensor to use and so on, how we want to display the results, and then we did the coding, while at the other side is more on physical items of the mechanism, the actual representation of the mechanism slider crank. So we designed the components as said before, and then we fabricate the design, which is all the components like disk, and so on, by 3D print. And then when all this is completed, we assemble the design, which the assembly design will be shown later in this presentation. And after that, we applied all the motions. We run the mechanism so we can collect the data. So after the data is collected and tabulated, the error between the comparison between theoretical calculation and actual data from sensor readings will be analyzed, so we can have numbers in terms of error percentage. And that's the end of the methodology.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zahiruddin bin Moha, and today I will be presenting you the product design specification. The components for this product is stepper motor, potentiometer, gyrometer, infrared sensor, Arduino, and finally LCD. Most of this component is put under this flat plate, and the mechanism is supported on top of the acrylic box. The blade plate length and arm length is based on the theoretical question and is 3D printed. Acrylic box is chosen because the product is not heavy and for aesthetic reason. This is the working of the product. The stepper motor under here will move the blade, and the blade will move the link, which move the link. Under the end of the link, there's gyro sensor. The gyro sensor reading will be read and displayed by the LCD, while the rotation speed is displayed by serial monitor in the computer. The potentiometer controls the speed of the rotation speed of the blade.
Assalamualaikum warahmatullahi wabarakatuh. My name is Luqman Haikal bin Abdul Aziz and I will explain about our component list. So based on this slide, we have two types of component, which is mechanical component and electronic component. So for mechanical component, we have slider crank parts which we have produced and developed by using the 3D pin, and also we have bearing for the rotation motion at the slider crank, and also we have a custom acrylic sheet for our product base. So for electronic component, we have stepper motor, potentiometer, and motor driven ULN 2003. So this electronic component is for the rotation motion, for the slider crank rotation. So for the sensor, we also have the accelerometer and encoder modular, which is accelerometer is to determine the acceleration of the slider crank, and also the encoder modular is to determine the speed of the motor. So for the output, we have the LCD display, and we also use the Arduino Uno R3 for our microcontroller, and we also have breadboard for the electronic component connection. So next we have circuit diagram. In this slide, we have separate into two types of circuit diagram, which is circuit for motor system and circuit for sensor system. The reason why uh, we have separate into two, because we have identified the problem that which is when we combine these two system into one system, we have identified that the speed of the motor are very slow, and the potentiometer cannot be functionality perfectly. And also for the output, the LCD display doesn't have show the output for the sensor. So to overcome this problem, we have separate the system into two, which is we have motor system and sensor system. That's all from me. Thank you.
So in this section, we'll see the results that we have gathered uh, both from theoretical calculations uh, using formulas and also actual readings from sensor. Okay, so first we have the RPM. So we have four different RPM. as said before in the problem statement, we start from 12 RPM, so the motor decelerates. So here it is in radian per second for the rotation speed. And then these are the theoretical value of the acceleration of the slider, which gotten from theoretical calculation using formulas. And these are the actual acceleration gotten from the fabricated mechanism, which the values are displayed by the sensor. So actually the actual readings, we have did more than one iteration, more than three actually, more than three for each rotation speed. However, we the chose only three nearest value at each rotation speed, and we find the average. So the actual acceleration here is actually the average value. And then from here we get to compare theoretical value and actual value and find the error.
So every project has their own flaws, just like our project. So this project would be better if the material for the most parts are being made from the steel or the aluminium instead of PLA. So the second one, the plate that represents the crank that being used in this project is actually will do well if it can be replaced with a simple disc or a fan with 4 blades with end tip at each of the blade. And lastly, it may be improved in terms of scale dimensions itself in the future. So after 14 weeks analyzing this project, we can conclude that the experimental results is relatively significant towards the theoretical results. We're also able to understand about the work principle of the study crank itself. And the most meaningful part in this project is that we are given the chance to utilize all sorts of technologies by ourselves in order to make this project successful.